When we have textures that are far away from the camera, from what we've learned so far, a scene can look kind of bad. And let me show you an example of a scene that doesn't look too good, using just what we know so far. It's supposed to be a checkerboard that extends infinitely in every direction. It's actually drawn as a giant quadrilateral with a texture applied to it. This texture right here, a checkerboard texture. And let me show you what it looks like using just what we've learned so far. It's kind of hard to demonstrate on a video like this, but I'll try. This is a screenshot. I'll just zoom in a lot. And you'll see when I zoom in that off in the distance, the scene doesn't look particularly good. It looks pretty ugly. It suffers from something called aliasing. And actually, like I said, it's hard to demonstrate this on a video, but if you want to see for yourself, you can go to the program and scroll down to Draw Scene. And right here, you can uncomment these two lines of code and comment out this right here to see how it looks, just using what we've learned so far. And why exactly can't we get this scene to look right yet? Well, let me show you using this animated picture. It'll start out by showing a 10 by 10 grid, or 11 by 11, which is supposed to represent the pixels in the image. And so these are the pixels. It shows this particular pixel and rotates the scene. And as you can see, this pixel right here actually covers a pretty large area on the texture image. It covers a lot of pixels in the texture image. And if I switch over to the image that we use for texture mapping right here, you'll remember that we actually represented each pixel as just a point on the texture image. So we were using at most 4 different pixels from the original texture image to represent one pixel that we were drawing onto the screen. But as I showed you in this picture, we actually want to use a large number of texture pixels from the original image. And in order to do that, we're going to use a technique called Mipmapping. And let me show you a mipmap right here. Basically, it's just a bunch of images. So you have your original image, your original texture image, which in this case is 256 by 256. Then you make a scaled down version of it, which is 128 by 128. You have a smaller version, which is 64 by 64, one that's 32 by 32, and so on, all the way down to 1 by 1. And as you can see, each individual image is anti-aliased. That is, this picture right here, for example, each pixel corresponds to a somewhat large area on the original texture image, and it sort of averages together all of those pixels that it covers in this image. So it sort of takes care of this averaging that we want to happen in advance. What we would want to happen is we would want to have this pixel right here, all of the area that it covers, we want to average together all of the pixels that it covers, more or less. And in order to approximate that, we're just going to use the mipmap, find the image that's the image for which the one pixel on that image is closest to the area covered by the pixel that we're drawing to. So using a mipmap, we can get a pretty good approximation of what something should look like when it's far away. And in the case of this checkerboard, this red and blue checkerboard, the pixels that are far away are going to look sort of purple rather than just red or just blue. Now, the way that we do mipmaps in OpenGL, it's actually fairly straightforward. I'll go up to this new function called load mipmapped texture, which is a lot like the load texture function that we've had in previous programs. The main difference is that instead of calling GL text image 2D, we call GLU build 2D mipmaps. And that makes it so that it takes the pixel data for the image and it builds all of these images. It gets them all set up so that we can use mipmapping. And once we've loaded in the mipmap texture right here, in order to use mipmapping, we just go down here and draw a scene. We send special parameters to the GL text parameter I function. So before we were using GL linear, which was blurry texture mapping. And here we want to use Mipmapping. So we'll use GL linear mipmap linear for the texture mapping type when the texture is far away. We actually have 4 options at our disposal for mipmapping. You can use GL linear mipmap linear, GL linear mipmap nearest, GL nearest mipmap nearest, and GL nearest mipmap linear. And basically, we have 4 options because, first of all, we can select to use either 1 or 2 of these mipmap images. So, in other words, if we have 2 images that are closest to the size of the pixel, the area that it covers on the texture, then we would take both of them and use the average for those. So, depending on whether this is linear or nearest, we'll use either 1 or 2 of these pictures. And we're using 2 in this case, so we'll have linear. And this parameter right here is basically the same as before when we had GL linear and GL nearest. It indicates whether we want to use just 1 pixel on whichever image it is we're using, or sort of average together 4 pixels that are near the point that we're considering. So those are the 4 different options we have for mipmapping. And we're using GL linear mipmap linear, which makes the scene look like this. And so if I show you right here a screenshot of the program and zoom in on it, you can see that off in the background the pixels sort of look purple. They're sort of red and blue averaged together instead of just red or just blue in this ugly looking screenshot that I showed you earlier. And that's the idea behind mipmapping. That's how we can use mipmapping to make textures that are far away look pretty good.